Good morning. I'm going to introduce today's speakers. My name is Juan Manuel Pico. I am a member of Regional Rafaela and part of the REM team. And in the co-creation workshop that we conducted, one of the topics that we decided to address here is this one today. As we said, water quality is an important matter and very relevant for applications and the effect of the agrochemicals that we apply. So we are going to have these high-level speakers that I'm going to introduce now. Gerónimo del Barco, agronomist engineer, specialist in plant protection from UCC, agricultural producer and member of CREA, production manager at Grupo La Tobiana, technical advisor and manager of AgroAdvance SRL, Juan Carlos Sampaoli, agricultural engineer, graduated from the UNR, agricultural advisor, and since 2020, technical manager at Banza Laboratorios, specializing in the analysis of phytosanitary mixtures, application quality, and technical assistance to clients of the company Ligier. And María Belén Aguer, Bachelor of Science in Chemistry from the University of Buenos Aires and Master's degree in Bioinformatics and Systems Biology from UNOVA. She currently serves as Global Head of Leaf Laboratories at Rizobacter, where she leads R&D projects focused on adjuvants and bioinputs, developing technical and scientific evidence and evaluation methodologies for foliar application technologies. We are going to listen to them, and please send your questions to the WhatsApp number you had on screen. So let's start now. Hello. Can you hear me? Good morning, everyone. I would like to start by asking all of you two questions, and I want you to be honest. Do you really know what a coadjuvant is? And do you know the water quality in your lands? Please raise your hand if you know that. Well, okay, above average. Good. So starting with one of the definitions, an adjuvant is any substance added to the spray tank to improve its performance. Basically, that is its main goal, and these are two bibliographical definitions. It is quite basic, but many people don't know. It is any product that helps the phytosanitary to work better. So we have active principles for our pesticides, and in this adjuvant world, they also have its own active principles, each one of them with their advantages and disadvantages. And these are the ones developed in the past 20 years. And in order to improve emulsions, the most technological ones are methylated oil emulsifiers and ethoxylated fatty alcohol. So as farmers, we know that the financial situation is not very easy. So in an application, we need to know what is the cost of an adjuvant and how much it represents. We always think of systemic products and all products, but the adjuvant is not very much considered in our budgets. And these are last year figures. In a chemical control, in high-quality soy, and with late corn, and we know how dirty they are, full of weed. Please see here, with 70-liter and 42 hectares, we ended up putting in a spray tank $1,400, equivalent to those active principles. And with pre-emerging, we ended up spending more, $2,300. There's the cost per hectare too. So how much does the adjuvant represent? Look, the first hit, 8.9, and in the second one, 5.5. And this represents all the things that we are investing in an application. And we can have a very important investment here, and I don't want to be too long, but a good adjuvant with a good mix can really help us improve the treatment with an investment cost that is really low. And now talking about my topic for today, I'm going to talk about water quality. The most important properties to determine water quality are the following: pH, electrical conductivity, total suspended solids, and hardness. And at REM, they told me, Gero, you will only have 13 minutes. I would need to define all of them, but I'm going to focus on the most important one, which is hardness. So I'm going to skip some slides, and I'm going to go directly to tell you that in pH, with the phytosanitaries, which are more stable, we have them mildly acid, between 4.5 and 5.5. And the phytosanitary products usually work well in this. And if we have high pH, we could have alkaline hydrolysis, and with too low, we could have precipitation and deactivation of some products. Electrical conductivity, the presence of salts, considering the same negative effect on products, and total suspended solids refers to suspended particles and organic matter. And going now to the most important part, let's talk about hardness. So what is hardness? We as a company, all of us here, when we talk about hardness, we are referring to the free cations present in water, like calcium. So why am I interested in this? Let's discuss that. This is not the only cation that we might find. There are several types, but the one that has the most important presence is calcium. So cations react with hormonal glyphosate, 2.4D, and others. And talking about glypho, which is where calcium is so relevant, let's say the following. When the industry discovered glyphosate, they ended up discovering the phosphonomethylglycinate, or an anion. And since this cannot be solved, the industry added a cation, an isopropylamine. So now when you buy glyphosate, you can find it with potassium, ammonium, just for this to be soluble, right? That is the main function. So basic chemistry, probably you all are engineers here and you will know this. If we put a molecule with a monovalent cation joined or linked to an anion with a high presence of a bivalent anion, what will happen? The calcium will link to the glyphosate, right? And part of the glyphosate is deactivated, and we could have different reactions here, and the money that we are spending on the active principle will not be useful because it will not be acting, right? So our investment in glypho is being lost. So if we have water quality, and this is why I asked you if you have high levels, you need to eliminate the calcium from this, right? Can we learn this or find this? Yes. We can give you kits or offer advice about what is your water quality with standardized procedures. And according to the water quality, we can find out how much money you are spending on glyphosate. And this is quite simple. Volume, the amount of water measured in liters per hectare, hardness, and a constant, and the calcium glyphosate complex. And this is very important. Why? Because maybe for logistic purposes, you already have the mosquito there, you need to apply, you don't have the good situation, then you shouldn't have a lot of water there, okay? Be careful with your water flow, because with the same hardness, you should see here how much we can deactivate by increasing the calcium presence. Just by increasing the flow, sometimes it's double. I will skip this, but of course, while cations have more charge, they will have more power, especially glypho. And this is for water quality purposes. This according to the hardness, if they are very soft, average, semi-hard, hard, or very hard. And usually we start working with regular waters, 250 ppm. Another negative effects of water hardness, it affects the emulsifiability and dispersibility of phytosanitary products, reduces the rate of absorption through the leaf cuticle, and generates scale and affects spray equipment. This is a picture that we received a couple of years ago, and I love to show this to create awareness. The first thing that we told the client was, please, safety measures, do not send this picture. But this is what can happen if we are not going to work with water. Going to a specific case, 3 or 4 years ago, let me try and remember this, when the war in Russia started, all the prices went up. And I remember that I was preparing a budget, and the cost for this was $16 per kilo. And I was going to use Control Max, and I was going to be spending like $50 or $60 per hectare. So with a study that we had conducted before, we said, okay, let's try to sequester the right way and reduce the dosage of glyphosate. And let's see how much we can reduce the glyphosate for control by sequestering. So you will see here what we ended up doing. We had service crops in order to assess what was going to happen. And then we ended up doing the controls to have 1.5 kilos with no adjuvant, as usually do with service crops. And then we reduced the dosage, and we would have the sequestering factors. But we had two water qualities, 250 ppm and 1,000 ppm, one soft and one not very hard. So where were the best results? In 1,000 ppm. Look here, at 250 we didn't have a lot of differences, and reducing the dosage, 350 grams. And then you will see the sequestering factor doing effect. And then with the highest presence of hard waters, we ended up having a higher difference. And this is the percentages of efficacy and control from 0 to 100. And the same thing happened with the rye, the same pattern. In hard waters, when we ended up reducing dosages with a sequestering element, results were quite clear. And also, something that I wanted to say that is not here is that we ended up having the same control quality with 750 grams of Control Max with sequestering factor compared to 1.5 kilos with no adjuvant. And in that case, you end up paying for the adjuvant even more. And I'm about to give the floor to my next colleague, but with emulsions, we need to take care of this. With small micelles that improve this, we need to be able to sequester. These are mix that we usually do. And we have here atrazine 90G with glyphosate potassium salt at 66.2 grams. You will see what will happen. The mix will not be the right way, and we will see this in our lands.
Hola, hola. Ahí está.
Hello.
Sí. Ahí estamos. Bueno, soy Juan.
Hello, I'm Juan Sampaoli. I was already introduced. We are going to speak now about formulations. Everything that Gero just said about water quality, its importance, how it affects us. Well, what we're going to see now is what are formulations. So basically what we manipulate every day when we start with our controls in the fields, those active principles that we choose depend on a formulation. What is a formulation? Is the way how those principles, active principles, arrive in the facilities and they are going to be used and controlled. So we know that there is an active part in a certain way and then other elements that we don't know, we are not sure how they are going to work out. Therefore, many times we confuse what an active ingredient or two glyphos that look the same are. They look the same, but they have different forms. One is solid, one is liquid. So all that originates from what the manufacturer did, how it was composed, so it is more effective in the field, it has more activity, or its handling is simpler. So within the formulations, because our vehicle is water, as Gerónimo just explained, we can split into two groups, products and formulations that are going to be part of a solution when they are added to the water. That is a homogeneous system. Once the solution is formed, it is irreversible and it is transparent when it is done in the correct way, of course. And the formulated principles that generate a dispersion of that formula in the water. There we find the WG, crystals, suspensions, concentrated suspensions, and emulsionable concentrates of micelles, of two invisible liquids that generate a dispersion. So in the field, we combine all these formulations, and there are interactions in the middle, of course. So to see which is the best way to combine all these products, we have an addition order. The addition order shows us how we are going to incorporate each one of these formulations to the water. Therefore, taking into consideration the formulations, this is the criteria of Mr. Maluf, Ernesto Maluf, that we think it is the best that adapts to the Argentine situation. So we go from the most complex aspect of integrating or dispersing to the easier. So that's how we work. So here, there is one exception because obviously this is not simple. You know that obviously the brands also pave the way. And this is theory, you know. The Ligier services, other colleagues as well, we conduct the different tests and combinations to see if the brands also obey these criteria or if we need to change something. So have a look. Here, what we're going to see is how we manipulate 2WG or what happens with 2WG, same active principle, same concentration of actives, two atrazines at the 90% WG, but with different brands. So if you pay attention, you will see that the one on the left disaggregates from the bottom up, and the other one floats and then disaggregates to the other way. So when I use each one of these brands, I will have to pay attention because if I alter the order of addition in the one that floats, and first I put one emulsifiable product, then it cannot disaggregate in the correct way. So it doesn't have this dispersion and it doesn't look the way it should. When we speak about order of addition, we see here an incompatibility of an antagonism. But apart from that, if I alter the order of addition, I can go from a situation that is practicable, irreversible, and obviously a problem, to the situation, like the situation on the left, or a situation that still keeps this antagonism. Because why? Because these are two solutions. And as I said before, the solutions should be transparent. They have to be transparent. So if I mix two solutions and you see this turbidity, that means there is something going wrong. But on the right, it can be recovered with some kind of product, a recoverer, and it can be recuperated. The one in the left is going to be a problem. Here we see, continuing with the order of addition, if we use different types of formulations, SC with a soluble product, this obeys the theoretic order. So these two formulations of these two brands obey the order of addition that I just mentioned. So we need to take into consideration that we are working in a complex system. There are many interactions going on with water quality that can magnify or not this, solve it or not, the formulations that we decide we're going to use when we have to perform any control with the phytosanitary. But we also have the human factor going on, because many times we understand these concepts, but because we are in a hurry, because we have other things to do, and things that we all know, we have this human factor involved that can also play against us. Therefore, what we do is, from Ligier Avanza, providing services of performance analysis, how the formulation works. There is also a factor that we use, that is time. We generate the combination of this phytosanitary. We see how its dynamic looks in statics, in time, and following these criteria that were worked by Ernesto Galuf, we adapt this chart. And what we see in time is, what does this tell us? If this can be a formulation, a mixture that we can use, if we need to have some kind of precautionary measure, or if it has a perfect compatibility, stable in time, and we can use it. So all this, when we analyze how the adjuvant, that is an external factor that we can use for stability, have a look here in this mixture. This mixture in itself is incompatible. Atrazine with paraquat, how we can incorporate an adjuvant that creates a microemulsion and it collaborates with stability of this mixture. Only by incorporating a product that can help us. In this case, this product, because of the type of formulation or mix or the treatment, this was a product that we were going to incorporate for quality purposes. So how we can create this microemulsion that helps us to have a stable product. Another factor to take into consideration when we perform the combination of phytosanitary is the rate, the application rate. Nowadays, we are working with drones, with other types of technologies, low volumes. Many times we need to lower the volume because of hardness reasons, to have less interactions. So when we lower the application rate and we take into consideration these type of measures, when we concentrate the products, when we work with rates that are higher, so then we are more relaxed. So to conclude, this is the mix of phytosanitaries. This is a complex system, as we could see, with different things, with different management, depending which formulations we are managing at the moment. So please take into consideration, as you, my colleagues, to perform the assessment at scale of the different combinations of the phytosanitaries. If you want to visit us in our stand. So thank you very much. Happy day for all of our agronomists here in the room, and see you later. Good morning, happy day, congratulations. Thank you very much for your introduction. Well, tank mixtures. This is a long road, and this is how we are going to see it. Which are the steps for a successful mix? There are many things that can lead us to wrong results. Let's try to find the way that takes us to a successful mix. Many things that are shown here were introduced by our colleagues: water quality, formulations, order of addition, agitation, application rate, product quality, temperature, adjuvants, equipment cleanness. So all this is a road, step by step. We need to consider each one of these steps to get to a successful result. And what is the key? Prevention. So on beforehand to consider all these aspects, so to not have any problem and apply other solutions that are more expensive. So water quality, we are going to go over very fast because Gerónimo just spoke about this. So to take into consideration the pH, hardness, knowing that pH is a property of water, but that can also be modified with the things that we can add to the tank. And we will see that later on. And something else is turbidity. We know that waters that are very turbid, that have organic matter inside, can also affect the efficiency of the control. Why? Because the organic matter can have affinity for active ingredients, glyphosate, for instance, and if we don't know that on beforehand and we are working with a turbid water, those active principles are retained in the organic matter, and we are applying less doses than the one that we are thinking. So let's try to work with crystalline waters, or as much as possible. In terms of formulations, Juan spoke a lot about that. The key here is, let's read what the formulations are. Let's read the labels. So if we have a mix of soluble things, then the mix has to be transparent. If we have a mix that has soluble things and others that are not, then the result of the mix will be turbid. If we have a formulation that has a suspension of solids or an invisible liquid in water, and we see that it's transparent, that is also not correct. Many times we want to have crystalline and fluid things because it's easier to apply. However, a mixture that has to be applied is not a mixture that is efficient. So as I was saying before, there are many factors that can affect pH. It's not only a parameter that lives in the water, and the water is going to determine how this value looks like at the end, but there are other factors that have an influence as well. Formulations, not only which formulations we are going to add, but which brands. The order of addition, load in order, and acidifiers. So what we are going to see now, it's a very brief example of a mix of phosphacene, fomesafen and glyphosate from two waters, different waters, soft water and hard water with different initial pH. So let's see what happens with fomesafen and glypho. The example we are going to consider now is how the formulations, regardless of the water quality, modify the pH parameter. So we added fomesafen in commercial doses in all the waters, soft and hard, and the 3 pH. So have a look. Initial pH, that has been the real pH. And for pH 6 and 9, soft and hard stayed the same. So we can say that fomesafen is increasing the pH in a water that was acidic at the beginning, and in the alkaline water it stayed the same. So what happens if we add glypho? It lowers, it decreases in all the cases. Glypho always at the end, as Juan said. Glyphosate solidifies more than anything. So that's why the idea is let's take it to the end, because the average of the Argentine waters has a pH of 8, 8.1. The idea is let's lower the pH slowly so we can get to acidic pH with the last product. Apart from that, because there are many products, as Gerónimo was saying, that with an acidic pH, they don't work very well. Have a look how it affects the solubility. If we have a pH 1,2, it's insoluble, and how it increases the solubility if we have a higher pH as the one in 9. So, order of addition from the most insoluble to the most soluble. So why is this? Because the most insoluble needs more energy to integrate. So we go from the most insoluble, we give it more time, we give it more energy, and as we start to add more things that need less energy to integrate, we move to the most soluble things. Following the other order, that it's more difficult to understand from the beginning, is to add things that modify less the pH, most basic things, to acidic things, ending with glypho. Agitation. This is important. An example of Juan, teribuzine and paraquat, difficult mixture. If we add adjuvants, that can favor, but sometimes it's not enough. So many times when we add WG or concentrated solutions, it's very important. So let's pay attention, because as we were saying, we have drones technologies, but they are not the same. So formulations that really need to be agitated to be in suspension and have an homogeneous application. Then application rate. Have a look how it changes the mixture of 2.4D with glypho. Here there are no brands, but obviously you know which are the brands that are being used to know if it's compatible or not. How it changes with a mixture at 40 liters and with 80 liters. The red one is to obviously increase the contrast. These solutions do not have this color, they are yellowish. So we know that with a low volume, happens that things that we thought were compatible are not compatible. So the test at scale is very important. Product quality, atrazine, same brand of atrazine and glypho, we change the brand of dicamba, a different result. So please know that brands do make a difference. If we have a mix with the same brands and we decide to change, let's perform the test first, because when you change the brand, then perhaps it doesn't work. Temperature. This is a very strange winter, many days that are quite cold, others that are not. So depending where we get the water can be very cold. Solubility and energy depend on the temperature of the water. The colder it is, less movement there is. So if it's cold, we need to give it more time because it's going to take more time to integrate. So here there is an important difference between 2.4D at 25 degrees and at 5 degrees. So obviously precipitation and energy play a role. Adjuvants. Many times we do all the rest, and however we see that things don't match and are not compatible. So there are two ways to think about compatibility with an adjuvant. Many times the mixes happen because of pH that are quite acidic, and that happens many times when we, for example, mix two herbicides, 4 of glypho, 2 of dicamba, or when we use for a concentrated solution glypho that lowers the pH and the suspension doesn't like it very much. So in those cases, one strategy can be to add a product that increases the pH so that the pH, whether it's compatible or an adjuvant that can increase the pH, then it's not so acidic and things can be compatible.
Another example of a use of a correcting agent in order to increase the pH, we have 2,4-D plus glypho or metribuzin WG plus 2.4-D mixed with herbicide, acidic herbicides. And maybe the final pH is not as important. The important thing is to give power to the suspension, to be able to suspend the solids and the invisible liquids in the emulsifiable agents, and in that case, the adjuvant, the idea is to have dispersing power, like, for example, micro-emulsion creating agents. And the idea there is to add them at the beginning, because if it already fell, it's hard to... I'm talking about suspensions and invisible liquids. It will be much harder to resuspend it than preventing that. This is why in mixes, prevention is key. The rest is very important, but if we do that in a dirty tank, it's helpless. And someone talked to us a few days ago and said, we're having a problem in our tank, and we didn't have any problems with correcting 2.4. It was a hard water that was corrected, and there was a very strong precipitation wide by the end of the mix that they were doing. And when we requested the pictures, they were doing the mix in glyphosate containers. So was it really the incompatibility of the correcting agent with the 2.4-D? No, the incompatibility was of the 2.4-D with the glypho, and that was being seen as incompatibility of the adjuvant with the herbicide. And finally, let me tell you, all the things that we've done are very important. This step-by-step journey will lead us to a successful mix, but we need to bear in mind that droplets have a surface, and that surface shall be treated in order to reach the target and have a real impact. This is why we need to use adjuvants reducing the superficial tension of the water, which is very hard, so that the droplets can reach there and the mix that we thought of so much can be efficient. So the idea is for us to be committed to efficiency and sustainability in order to make the best growth possible. Thank you. Thank you very much. Thank you for your 3 presentations and for complying with the time given. We have the WhatsApp open for you to send your questions. And if you want to ask them directly, you can raise your hand and we can give you a mic. Gero, first question for you so that your colleagues can rest. Regarding water quality, Juanqui already talked about this. With the low volume and thinking especially of the drone application technology, what can you tell us and maybe reinforce some of those concepts? Yeah, drones is something in fashion now as an extra tool, and at the general level, basically, With hard waters, it is harder, but without them, when we reduce the volume, bear in mind that we are mixing different active principles in a smaller concentration of water. So this ends up raising the bar mainly in the stability of the emulsion that we are creating. Therefore, you need to have the right advice of a good adjuvant company in order to know what specific adjuvant is recommended for that flow of water. Regardless of the presence of hard waters or not, with hard waters it is even more complicated. And always bear in mind that reducing the flow of water will complicate the stability of the mix, okay? And we have the experience of planes generally, but this can be applied with fungicides or insecticides or chemical mixes of herbicides, which are not as complex. The drone specifically is replacing the spray that we do, for example, with late corn, for it to be clean of weed in order to avoid any problems. And this is more superior than what we are doing with planes. So we are trying to create a specific emulsion product for drones. We already have that for terrestrial equipment, but with drones, in the past years, we've seen an agent low concentration, especially in low volume, and that is the complication. Please raise your hand and remember to ask your question to the microphone. Okay, so one more. Okay, one more. With regards to biological product application, what would be the right formulation, and how will this play with the addition of adjuvants in the reaction of the tank mix? Okay, with regards to biological products, there is a large diversity of types of formulations because it is not the same when we work with biofertilizers or biostimulants, where we need to take into consideration certain complexity and the function, what is going to be their reaction, because some of them are more alkaline and are usually combined with a treatment that might affect us. So we need to work on the medium so that the active that has the phytosanitary function can really exercise that, and the biostimulant needs to biostimulate by reducing superficial tension and penetrating on the plant. But also we have other products such as among the biologicals like fungi, spores, bacteria of living organisms, where we need to handle that. And then the criteria is more related to the application quality. The formulation is important, knowing whether we can combine these with some phytosanitary products or not. And we work a lot with compatibility tests. Ligier products are all compatible with biologicals. But we've been working a lot, and tomorrow we're going to be having a presentation on this. And we need to understand how this will be solved. And we need to know whether this is going to be bacteria or fungi. So we need to know how they're going to be combined. I am leaving you with more questions than certainties, but well, this is what it is. And the last one for Belén. You talked about the temperature. How can this affect the mix? Do we need more agitation time? Yeah, we need more time for it, especially for the elements that needs to be suspended, like dispersible granules. But with all formulations with less temperature, they need more time and energy. Therefore, If it's cold, be patient. Very good. Unfortunately, we won't have time for any more questions. The speakers will be here, so you can see them at their booth. From REM, we would like to thank you for being here, and let's continue.